Okay, in this video I'm going to guide you through how to solve some slightly more unusual trigonometric equations that you might encounter in your circular functions criterion part of the test. Okay, so this first one is from a 2014 paper, part 1. And of course this is trigonometry, so it's section B, because section A is function study. Okay, now this is the question. Solve 2 cos squared theta plus 5 cos theta equals -2 for theta in the interval 0 pi. Okay, alright, now this equation is not in the usual form that we would expect. Okay, we know that trigonometric equations, the kind that we learn how to solve in methods, are all written in the following form: cos ax plus b equals k, or sin ax plus b equals k, or tan ax plus b equals k. Those really are the only trig equations that you know how to solve. So that means that any other equations are going to have to be brought back to some of these. Okay, now if we go back to the original equation, hopefully you'll have developed the correct mathematical reflexes by now, and you will rearrange your equation to this form. And you will say to yourself, it looks like some sort of substitution is going to be required and we're going to end up with a quadratic. And indeed, if we let x equals cos x squared, cos x, or cos theta, the equation can be rewritten 2x squared plus 5x plus 2 equals 0. And that is a quadratic which we know how to factorise. Now I'll leave that factorisation step for you to review, because that's simply a little bit of basic stuff from year 10, but that factorises to 2x plus 1 times x plus 2 equals 0. Yes? So we know how to solve this using the null factor law, of course. That leaves me with x equals -2 and x equals -1/2. Okay, so because cos theta is what's equal to x, if we substitute back, it means that we're trying to solve these two equations. Now we know that cos theta cannot be equal to -2, because it doesn't matter what angle theta is, its cosine and sine values can never be greater than 1 or less than -1. As a result, this has to be rejected, as cos theta has to be in the interval -1 to 1. Therefore, we're left with a relatively simple equation to solve. Okay, so cos theta equals -1/2 is the equation that we have to solve. So that is pretty straightforward. Okay, so hence we want to solve cos theta equals -1/2 with theta over the interval 0 pi. Well, we know how to do that. If we use our usual little list, our base angle, now which angle has a cosine of 1/2? The base angle is pi on 3. Likewise, if we look at the quadrants, we draw a little trig circle. Negative value of cosine is quadrants 2 and 3. Now be very careful. If we look at the domain, excuse me, we're only looking for solutions between 0 and pi. So we're only looking for that solution there. Okay, so solution is in quadrant 2. Therefore, theta is going to be equal to pi. Take pi on 3, in other words, 2 pi on 3, and that is our solution. Therefore, theta equals 2 pi on 3, and that is our only solution.